So let's take a look at our solving quadratics by factoring. Okay, and this is the next step now that we've learned how to factor our 5 different ways of factoring. Now we're going to talk about how we can actually go about solving. All right, so let's talk about what that means first with solving. So it says here to find quadratic solutions, and we can use other words in order to say what a solution is. We're going to refer to them as roots, zeros. You can hear them be called x-intercepts. There's a bunch of different terms that we're going to use when we're referring to solving. Okay, so instead of just graphing them, okay, we're not gonna go through and graph them. We're going to talk about that later on. Okay, so let's take a look at this example here. It says find the solutions of the equation y equals x squared plus 3x minus 10 by factoring. So the first step, and this is always anytime it says solve, okay? Whenever it says solve, the first thing is always to set it equal to 0. So that's what we're going to do. We're going to have x squared plus 3x minus 10 equals 0. Okay, we always want to set our equation on the left-hand side, our expression, and make the right-hand side 0. Okay, then we're going to factor the left side down. This goes back to what we've been doing over the last week and a half or so by saying, okay, how many terms do I have? I have 3 terms, so that means it's either going to be a basic trinomial or a slip and slide. Well, because this leading coefficient is 1, that tells us that it is a basic trinomial, right? So that's the process we need to do in order to figure out what type of factoring we need. So again, basic trinomial, what 2 terms multiply to negative 10, but are going to add to give us the positive 3. Okay, so negative 10, we can do that by a positive 5 and a negative 2. And then 5 plus negative 2 gives us the positive 3 that we need. So that tells us that the factors that we have are a positive 5 and a negative 2. So remember, factor means our parentheses. So that means we have our x plus 5 as one factor. And then we have our x minus 2 as the other. Okay, and again, it's still set equal to 0 here. All right, so now it looks a little bit different from what we did before, where now I have my factor, but it's set equal to 0. All right, so that's step 2. Step 2 done. Step 3, it says set each factor equal to 0. That's a typo there. Equal to 0 and solve for x. So here's what that means. That means take your first factor, x plus 5, and set that expression equal to 0. And then take our second factor, x minus 2, and set that equal to 0. Okay, so we're taking both of our factors, setting it equal to 0. And what you should notice is that when you solve, it's just a one-step equation, right? How do I move the 5 over to the other side? Right, because I want to get x by itself. So if I move the 5 to the other side, I subtract the 5 on both sides, and that gives me an answer of x equals negative 5 for the first one. And then if I do the same thing over here, I need to move this negative 2, so I do the opposite operation. So I'm going to add the 2 onto both sides. And that gives me an answer of x equals positive 2 for the second one. All right, so these are our 2 solutions. Right? If we actually went through and graphed this, this is a quadratic equation, so it looks like a U, right? And what we would notice is that this graph would actually cross at 2 points on the x-axis, and it would actually cross at negative 5 here, and positive 2 here. Okay, those would be the 2 places that it would cross at. All right, so these are our solutions. So the last thing it says is write your answer in curly braces. So that's what that means is like this. We have x equals, because that's our solution, we're solving for x. And then we have a curly bracket here of -5 because we want to put these in numerical order, then a +2, and then we're going to close our brackets, right? And that is our final answer. So when it says find the solutions, my solutions are -5 and +2. Pretty good, right? Okay. So again, it comes down to knowing which way you have to factor each problem. All right, so let's take a look at a couple of different ones here. Okay, so we can see by every single one of these, right? Every single one of these on this page is the same type of factoring. Do you know which one it is? Okay, if you look at which type it is, they all have 1, 2, 3 terms. 1, 2, 3, 1, 2, 3. They all have 3 terms, and the leading coefficient in every single one of these is in fact 1. So that tells us that for all 6 of these problems, we're using a basic trinomial method. Okay, that's the same thing of what 2 numbers multiply to give me 3, but add to give me +4. Okay, that one's pretty simple. That gives us a 3 and a 1. Okay, so I can finish this problem pretty quickly. I can factor the left side into an x plus 3 and an x plus 1. Right, still setting it equal to 0. And now I can take each one of my terms, take the x plus 3, set that equal to 0. That should be a 0 there, there we go. And then take the x plus 1, set that equal to 0. And then I solve both of them, right? I subtract the 3 on both sides. That gives me an x equals -3. And then I subtract the 1 on both sides, and that gives me an x is equal to -1. So those are my 2 solutions there, -3 and -1. But again, that last step of writing them in curly braces is important. So I have x equals curly bracket, go in numerical order, so the smaller number first, -3. Let's make that look like a 3. And then -1. And then we'll close that out. Okay, so there's our solution, -3, -1. Okay, let's do one more of this type real quick. Okay, so let's take a look here at number 4. Now number 4, this one's got a negative here, but it's set up correctly, right? If we look at our steps, step 1, set the quadratic equation equal to 0. Already done with that. Step 2, factor. And we already said it's a basic trinomial. So the 2 numbers that multiply to -27, but are going to add to a +6. Okay. Now, -27, we know that's 9 and 3, right? Or -9, +3, or -3, +9, right? That's the only way we're going to get 27 is with 3 and 9. So we know those are the 2 numbers we need. But which one of these has to be the positive one and which one has to be the negative? Well, because my addition is positive, that means my bigger number has to be positive. So the -3 has to be, or the 3 has to be negative. Okay, so let's write our factors. We have x minus 3, and we have x plus 9. There we go. Okay, is equal to 0. We're going to set both factors equal to 0 here. So x minus 3 and x plus 9. There we go. Okay, so then we're going to do the opposite of each one, right? That's what you should have noticed so far, is that your answer actually is the opposite of what you're adding or subtracting. So if I have x minus 3, that means that I'm adding 3 onto both sides to get x by itself. That gives me x equals +3 as my first one. And then I'm going to subtract 9 on both sides because it's the opposite of addition. And that gives me x is equal to -9. Okay, so we have our 2 solutions of -9 and +3. So we have x is equal to -9 and +3. There we go. Okay. All right. So you go ahead and do number 20 or number 5. Okay. You go ahead and do number 5 here. Take a couple minutes, pause this video, and then when you're all set, go ahead and continue the video to see what the solution is. Okay. All right. So I'm assuming that we have problem 5 all ready to go. So let's take a look at what problem 5 looks like. Now again, we have a basic trinomial. It's already set equal to 0, so all we have to do is just do the factoring. So let's take a look here. I'm multiplying to a positive 21, but I'm adding to a negative 10. Okay. Now, if I'm multiplying to a positive, just like we did up here, okay, I'm either having both of my numbers be positive or both of my numbers be negative, and it's all dependent on what your addition is. Because my addition here, number 1, was positive, both my answers here were positive. Well, because my addition here is negative, that means both of my numbers here have to be negative. And again, how do I get 21? There's only 2 numbers that multiply to give us 21, and that's 3 times 7. And again, 3 and 7 do make 10, but they both need to be negative. Okay? So that tells us that we have a -3 and a -7 here. So we are going to do x minus 3 and x minus 7. Okay, still set it equal to 0. Then we're going to set both of our factors, the x minus 3, the x minus 7, equal to 0. And I suggest that you do this every time, even though you might be thinking in your head, oh, I already know that it's going to be +3, +7. Go ahead and double check. Oops, I'm getting ahead of myself here. Go ahead and write these out, because when we get to some of the ones here in a little bit that you have to do more than one step for, you want to get into the habit of writing these out. Okay. So then we do the opposite, x minus 3, I add a 3 on both sides. That gives us x is +3, x minus 7, I add 7 on both sides, so I get that x is +7, right? So those are our 2 solutions, our 2 roots, whatever you want to call them. And so we get that x is equal to, and again, we go in numerical order, +3 and +7. Good. Okay. Now, again, all 3 of these were all basic trinomials. Let's take a look at some that aren't. Okay. So let's take a look here at number 9. Number 9 is a pretty good problem. Now, the first thing that we always have to look for in any sort of factoring problem is what? Do you remember? Factor. A GCF. Okay, we need to factor out a GCF no matter what. Now, in all the other ones we've done, there's been no GCFs in any of these. Okay, but if we look at number 9, I have 2 terms. So the first thing that I need to look for is a GCF, and I do in fact have a GCF because both terms have an x. And so that's my GCF there is x. And then what do I multiply x by to get x squared? X. What do I multiply x by to get -8x? -8. Okay. So at this point, I would normally look at what's left inside my parentheses. Now inside this parentheses here, it's x minus 8. There's no GCF, there's 2 terms, but there's no perfect squares. So I can't do difference of squares here. So this is actually the fully factored form. So what's nice is I have my 2 factors. My first factor is x. My second factor, x minus 8. So I'm going to do the same thing that it says here. Set each factor equal to 0. So I'm going to set my first factor, x, equal to 0. Set my second factor, x minus 8, equal to 0. And I'm solving for each. Well, guess what? This one's already done for you. You already know your first one's going to be x equals 0. For your second one, you have to add 8 onto both sides to give us a solution of x is positive 8. Okay, so these types of problems are very simple because one of them's already taken care of for you. When you factor out that GCF, you have to set that GCF equal to 0 in order to know whether or not it's a factor, or a solution, sorry. So we have that x is equal to 0 and positive 8. Okay. All right, let's take a look at a couple more here. All right. So let's take a look here at number 13. Now again, number 13, we want to look for a GCF first. Do I have a GCF between x squared and 64? No. There's no common term. They both don't have x's. So I ask myself, how many terms do I have? I have 2. That leaves me with only one option to factor, and that's the difference of squares. So with the difference of squares, we ask, do I have 2 terms? Yes. Do I have a subtraction sign? Yes. Then I ask, what do I square to get x squared? I'm squaring x. And then what do I square to get 64? That's right, I'm squaring 8. So now we have our factor. We know that when we do difference of squares, the 2 things I need are what I'm squaring, the x and the 8. And what am I going to do with that x and that 8? I'm going to add it in one binomial and subtract it in the other. And again, it's still set equal to 0. So now I'm in the same situation as every other one that we've done. We take the 2 factors we have. We set it equal to 0. So we have x plus 8 equals 0. And x minus 8 equals 0. And guess what? We just get the opposite. If x plus 8 equals 0, subtract 8 on both sides, we get that x is negative 8. Okay, if I add 8 on both sides, then I get that x is positive 8. Okay, now with negative 8 and positive 8, you could write it in 2 ways. We could write it as negative 8 and positive 8. That's perfectly fine. Or we could write it as x equals, and then again in brackets, positive or negative 8. Okay? Either way is correct. Okay? Doesn't matter which way you write it, but they are saying the same thing. Positive and negative 8. Positive and negative 8. Okay? Why don't you go ahead and do number 16 for me? Okay? You go ahead and do number 16, pause the video, and when you're all ready for that, then continue on with the video. All right, so I'm assuming number 16 is already done. So we're looking at 16, set equal to 0, good. Is there a GCF between 9 and 49? Well, 49 can only be divided by 7. Can't divide 9 by 7, so there's no GCF there. I have 2 terms, subtraction sign. What do I square to get 9x squared? I'm squaring a 3x because this is a difference of squares. What am I squaring to get 49? We already talked about that. We're squaring 7. So now I have a 3x minus 7 and a 3x plus 7. So let's do that. 3x minus 7 and x plus 7. And again, set equal to 0. All right, now this is the first one that we've done so far where actually our x has a coefficient that's not 1. Every other one that we've done, all of the x's have had coefficients of 1. So this is the first time that we haven't had that. Nothing changes here though. We just have a 2-step equation to solve. All right, so we're going to take both of our factors set equal to 0. So we have 3x minus 7 gives us 0, and 3x plus 7 gives us 0. Okay? So we're going to solve each one. Again, it's a two-step equation now. So remember, with two-step, you always want to get rid of your addition or subtraction first. So in the first one, we need to add 7 on both sides. Okay, that leaves us with 3x equals positive 7. If we do it on the same thing on the other side, we subtract 7. Okay, so again, you're just doing the opposite here. So that leaves us with 3x is equal to negative 7. And from here, we just have, again, a one step where now I need to divide by 3 because I'm multiplying by 3 with the x here, so I do the opposite. And both of these are the same. So I'm dividing by 3, and that leaves me with an x is equal to, and I actually can't reduce 7 over 3, so I leave it as 7 over 3. Same thing over here, I leave this as negative 7 over 3. Okay? So again, we can write this in two ways. I'm just going to use the way that I normally write it, which is a positive negative 7 over 3. Okay? There we go. All right. Okay. Let's go ahead and do a couple of these real quick, and then that'll be it for this video. Okay? Now, as you can see in every single one of these problems, not a single one is set equal to 0. And remember, that's the first thing that has to be done. Okay, so when I look here at number 17, I need to set this equal to 0. Now this is a positive 21. So how I move this positive 21 over, I subtract it, right? You do the opposite. So if I subtract a 21, and I know that looks like a 4, but it's not, it's a 21. That gives me x squared plus 4x, but now I have a minus 21, and now I'm set equal to 0. Okay, now it's in the type of equation that we had over here, right? Same type of equation here, all right? Now, I'm going to set these ones up first, okay, because I know I need to set them up. So I'm going to set them up before I go through and do a couple of them with factoring. Now, if we look at 18, I need to move this 4x over. Now, remember, the 4x, it has to come after the x squared. It can't come at the end, right? The 21 went on the end because it's the constant. 4x is not the constant. Now, this 4x is positive, so again, I need to subtract it. So that means my equation is going to say x squared minus 4x, because it has to be in standard form, and then I still have this minus 45. Okay, set equal to 0. All right, same thing here with number, let's look at number 20. Okay, number 20, I have to move the 4x and the 1. Well, guess what? The 4x is going to be subtracted, and it has to be combined with the other value of x, that negative 10x. This negative 1 has, or this positive 1 has to be subtracted, and it can only be subtracted from the constant of 49. So the x squared does not change. Negative 10x minus 4x gives us a bigger negative of negative 14x. And then 49 minus 1 gives us a positive 48. Okay? So again, we're setting it up here. All right? Same thing with 21. Now notice I have an x squared and an x, so they have to go in that order. Subtract the 28x to the left, right? We're subtracting 28x, so that leaves us with 4x squared minus 28x equals 0. Okay. Looking at 21, I have to subtract the x squared. That has to go with the 11x squared. And then the 8x has to be subtracted as well, but that 8x isn't going to be attached onto here. It's going to be next to it, right? So that tells me 11x squared minus 1x squared. That gives me a 10x squared. Sorry for that. Mouse slipped a little bit. That's a 10. You know what? I'm going to rewrite that for you guys. That's that looks pretty rough there. Okay. So again, we have a 10x squared, and then I'm subtracting the 8x, so that's a minus 8x equals 0. All right, so again, every single one of these I had to set equal to 0 first, then I got myself into the correct situation where I'm set equal to 0. Now I can go through and factor. Okay, so why don't you guys go ahead and take the next handful of minutes, work on these, okay, and you know, we'll go over these in the next video. All right, make sure that you do your homework that's with this, and make sure that you do the ALEKS assignment that goes along with our factoring and our solving as well. All right, okay, that's it for this one. Be on the lookout for another video coming soon. Thanks.